All right, so the last problem on the final exam review is question 15. It says this. The data shows the energy consumed in 1 year for a random sample of households from 4 different regions. Okay, let's see. All right, so there we have it. Can you conclude that the mean energy consumption of at least one of the regions is different from the other? They want us to perform a one-way ANOVA and see if there's a difference between the 4 averages. So we got 4 groups. We got Northeast, we got Midwest, we got South, we got West, and then we have a mean for each one of those, okay? So we got the population mean here, we got the population mean here, the population mean here, population mean here. Well, populations are too big, so we take samples for each one of those. And now we want to compare the samples to see if we can make an educated guess about the populations. So there's our sample right there in that data that you see. All right, so we want to see if these averages are the same or if they're different. The null hypothesis, of course, says that they're the same, right? That group 1 is the same as group 2, which is the same as group 3, which is the same as group 4. And then the alternative hypothesis says that at least one is different. I don't know which one, but at least one is different. All right, so there's the null and the alternative hypothesis. The null says they're equal. The alternative says at least one is different. Let's see which one's the claim. Can you conclude that the mean energy of at least one is different? So it looks like our claim is the alternative. All right. So let's figure out, look, that looks like, for me, that looks like B. Yours is probably different, but here's that. All right, next, the critical value. So to find the critical value, we're going to have to do something a little bit different because what we're used to finding critical values on tables. But for this one, it's a little bit different. How we find the critical values is you have to find the degrees of freedom for the numerator and the degrees of freedom for the denominator. And the degrees of freedom for the numerator, what we do is we take, they say k minus 1, but what k is, that's the number of groups. Okay, so in this case, the degrees of freedom in the numerator is how many groups we got? We got 1, 2, 3, 4 groups. So that's 3 degrees of freedom in the numerator. We'll do that in just a second. The degrees of freedom in the denominator is capital N minus K. Well, what's capital N? That's the total number of sample size. So we got to take the sample size from each group and add them up to get the total number of sample size. And then we know what K is, right? K is the number of groups. All right, so let's see what's going on in this case. Back to the data. Click on that. Let's see what we got. We got 1, 2, 3, 4, 5 here. 4 here. So we got 5. Maybe I'll keep track. 5 plus 4 plus 6, I think. 2, 4, 6. Plus 2, 4, 5. 5. So that's a grand total of 20. And then we have to 20 minus how many groups? 4 groups. So 16 degrees of freedom in the denominator. 3 in the numerator, 16 in the denominator. Now we also have to keep track of, well, what's the alpha value? The alpha value should be given. My alpha value is 0.05. All right, so how do we find our critical value? Is in StatCrunch, go back to StatCrunch. In StatCrunch, we go to the F statistic calculator. So we go to Stat, Calculator, F, and then it asks for the degrees of freedom in the numerator. There it is, 3. Degrees of freedom in the denominator, 16. And then we want our alpha value to be 0.05. So I put that over here. That will give you the total area, 0.05, out on the tail. I want that out on the tail, please. Okay, there it is. All right, so there's my critical value. There it is. Two decimal places. All right. Make sure you round up if you need to. There it is. All right, so here's my F statistic. Again, it's just one tail. And my critical value ended up being 3.24. All right, so there's the borderline. We will reject anything out on the tail, fail to reject anything that's inside. All right, so where is the rejection region? Anything greater than 3.24. And now it says, well, now take the sample that you have and convert it to an F statistic. So we got to take our samples, upload them in a StatCrunch, and let's get that F statistic. Stat. Oh, goodness. Where is it? ANOVA, one way. ANOVA, one way. Select all of the columns. That should be good. And I'm looking for that F statistic. There it is. All right, they want that to 3 decimal places. That rounds that up to a 20 then. All right, so my F statistic was 4.22. Let's see where that is. My sample data is 4.22 when converted to an F statistic. That is past the borderline, right there, past the borderline. That tells me we need to reject the null hypothesis. These groups are not equal. One of them is different. Reject the null hypothesis. Decide whether or not to reject or fail to reject the null hypothesis. It is in the rejection region, so reject the null hypothesis. And then it says, well, tell me about the claim. Choose the correct interpretation below. All right, what was the claim? The claim was the alternative hypothesis. The alternative hypothesis, remember the null hypothesis was rejected. The alternative hypothesis then is supported. So there is sufficient evidence to support the claim that there is at least one different. All right. There we have it. Good luck on the final exam.